Good morning. I'm James Imperial, and let me present to you the technology of carbon capture and storage. It is an innovation that is designed to capture CO2 emissions to prevent it from entering the atmosphere by any of three ways. Post-combustion, the most common, involves isolating CO2 from the exhaust gas stream after combustion by running it through an amine solution in which CO2 is soluble. The CO2 is then liberated from the amine solution where it is compressed and transported for storage. Pre-combustion involves gasification, which means reacting the fuel at high pressure and temperature in order to produce a synthesis gas containing CO2, CO, and H2. The gas stream is further reacted with water to convert CO to CO2 and H2. H2 is used as fuel, CO2 is captured and stored away. Oxy-fuel combustion is similar to post-combustion capture, except that the burning is done in an artificially created oxygen atmosphere instead of in air. The gas stream then has higher CO2 concentration. Water vapor, also in the gas stream, is easily isolated through cooling and compression. The near pure CO2 is then captured and stored. The technology has the potential to reduce CO2 emissions in fossil fuel plants by 80 to 90%. Captured CO2 is then piped down into any of the three geological formations, depleting gas or oil fields, deep saline aquifers, or unminable coal seams. There are four trapping mechanisms in which the gas can be contained: structural storage, residual storage, dissolution storage, or mineral storage. Now if we look at the data collected by the IPCC, it shows the breakdown of greenhouse gas emissions by source, in which the largest are energy at 26% and industrial at 19%. It is possible for CCS to be installed in these three sectors as they have definite gas exhaust systems as seen in their cooling towers. The technology, however, is mostly applied to energy plants, but not that utilized in industrial plants. Now is definitely the time to extend it to the industry, particularly to the three sectors with the largest emissions: chemicals, aluminum, and cement. If implemented, emissions can potentially decrease by as much as 36%. The original method for releasing CO2 from the amine solution is by heating, which requires about one-third of the heat generated from the combustion process itself. The MIT Energy Initiative has recently developed a CO2 desorption technique called electrochemically mediated amine regeneration. The amine solution is run through an electric current where electrocycling of copper metal and copic ions in the amine solution desorbs CO2. This requires significantly less energy, making CCS cheaper to implement and therefore more feasible. Though unminable seams are scarce in the Philippines, oil and gas fields are abundant with locations in Luzon, Mindanao, and offshore in the Sulu Sea and West Philippine Sea. CO2 can be transported via pipeline, through land, and via container ships to offshore fields. Compressed CO2 can also be utilized in oil extraction, which is known as enhanced oil recovery. In this application, CO2 injected into the oil field increases pressure in the reservoir, helping to sweep the oil towards the production wells. The need for pumping is therefore lessened, saving energy. Selling this CO2 to companies to extract oil could lessen the costs of CCS and move the technology forward. The CO2 emissions of this country has dramatically risen in the past half century. As of 2010, 22,250,000 metric tons of CO2 was produced by the Philippines. And even though our emissions only make up 0.26% of global emissions, it must be pointed out that we still continue to industrialize, meaning these numbers will increase. We still remember that CCS is not an incentive for us to continue using fossil fuels. It is only there to slow down CO2 emissions as we slowly transition to renewable energy sources in the following decades. We have exceeded the 1 degree mark in global temperature increase and are close to exceeding 2 degrees Celsius. We need to keep CO2 concentration in the atmosphere at 450 ppm if we are to prevent this. CO2 levels will definitely exceed this number before complete transition to renewable energy sources like solar and wind, unless we start implementing CCS in all our CO2 emitting facilities. Now here are two patents making use of the technology in applications which do not focus on the storage. The focus is instead on the production of useful compounds from the gases isolated from CO2 after capture. The first one synthesizes polyolefins, while the second one produces various hydrocarbons such as methane. These are my references. Thank you for listening.